Here is what every textbook tells you about the Great Pyramid of Giza. Workers dragged 2.3 million stone blocks up a massive external ramp. The blocks sat on wooden sledges. Workers poured water on the sand in front to reduce friction. Over 20 years, one block placed every 2 to 3 minutes continuously during every daylight hour. The pyramid rose to a height of 146 meters. When construction was finished, the ramp was dismantled and removed. Nothing was left behind. That's the standard answer. You'll find it in archaeology textbooks, in museum exhibits, and in virtually every documentary about ancient Egypt. It's what most professors will tell you if you ask. And when engineers actually apply construction physics to it, real material volumes, real gradients, real timelines, the math doesn't close. Today we're doing something most ancient history content never does. We're going to present the official theory as clearly and fairly as possible, and then show you exactly where it breaks down. Not one place. 3. And the third one is the part of the pyramid that the ramp theory doesn't address at all. Stay with us, because what emerges when you actually run these numbers is more uncomfortable for mainstream archaeology than the original mystery. Let's start with the strongest version of the official theory. Ancient Egyptians were sophisticated administrators and skilled engineers. In 2018, archaeologists excavating a site called Wadi el-Jarf, an ancient port on the Red Sea coast, discovered a set of papyrus scrolls written during the reign of Khufu, the pharaoh who commissioned the Great Pyramid. The scrolls were written by a work supervisor named Merer, and they describe in precise administrative detail teams transporting limestone casing blocks from the quarries at Tura across the Nile to the Giza construction site. This is direct contemporary documentation from inside the construction project. It's one of the most significant Egyptological finds of the last century. The ramp model fits this context. Average pyramid blocks weighed around 2.5 tons, a 2014 study in Physical Review Letters, testing the physics of wet sand specifically, confirmed that wetting sand by the correct amount roughly halves the force required to pull a loaded sledge across it. A wall painting from the tomb of Jehu'tahotep, dating to around 1900 BC, shows a large statue on a sledge being pulled by workers, with a figure at the front pouring liquid onto the ground ahead of it. The technology was real. The organization was real. The labor force was demonstrably real. That is the best case for the ramp theory. Now let's apply engineering to it. The governing constraint of any ramp is gradient. Too steep and a loaded sledge cannot be pulled up by a human team. The practical maximum, the figure Egyptologists themselves use when modeling ramp construction, is 8%, a 1 in 12 slope. At 8% gradient, a ramp that reaches the top of the Great Pyramid, 146 meters above the plateau, must be approximately 1.5 kilometers long. Not 200 meters, not 500 meters, 1.5 kilometers. There is no space on the Giza Plateau for a ramp of that length. You can verify this immediately on any satellite map of the site. The surrounding area cannot accommodate it. But length is not the most critical failure. Volume is. A ramp 1.5 kilometers long, at the width required for a functional 2-lane construction operation, wide enough for loaded sledges to pass in both directions, wide enough for the teams hauling them, would contain approximately as much material as the pyramid itself. To build the Great Pyramid via an external ramp, you would first need to build the equivalent of a second Great Pyramid out of ramped material, using the same workforce, in the same 20 years, and then dismantle every trace of it when you were done. A 2022 engineering analysis modeled the energy and material constraints directly. The conclusion: the external ramp, extended to full pyramid height, fails on volume alone, before accounting for the labor required to construct and remove it. Egyptologists who acknowledge this typically propose a modification, a spiral ramp circling the outside of the pyramid rather than climbing one face, or a series of shorter ramps dismantled in stages as the structure grew. These proposals solve the length problem, but they create a different one. No physical trace of any ramp configuration has ever been found at Giza. No compacted ramp fill, no sledge wear marks on the plateau surface, no retaining walls, no infrastructure of any kind. For a construction project that moved 6 million tons of material across 2 decades, there is zero archaeological signature of how that material was moved. Stay with us, because what comes next is the section of the pyramid the ramp theory cannot address at all, and what's striking is how rarely it comes up. The king's chamber sits roughly 60 meters above the base of the pyramid. Above the chamber's ceiling are 5 separate granite vaults, stacked one on top of the other, containing 43 beams in total. Each beam is not limestone quarried at a nearby site. It is granite, brought from Aswan, 800 kilometers up the Nile, and each one weighs between 50 and 80 tons, the same weight as a fully loaded passenger aircraft. These beams had to be raised 60 meters and positioned with sufficient precision to sit flush against the chamber walls already completed below them. The ramp theory provides no mechanism for this phase of construction. The mainstream archaeological literature does not propose one. Engineers who have modeled this specific problem using ramp assumptions have found that the angle required to slide an 80-ton granite beam up to that height, even with lubrication, even with a large hauling team, generates friction forces that exceed what any documented ancient technique could overcome. The geometry does not allow it. This is structural engineering, not speculation, and it is the part of the Great Pyramid that the standard explanation leaves completely blank. So what do the competing theories look like? The ones that survive the same tests the ramp fails? In 2006, French architect Jean-Pierre Houdin proposed an internal ramp, a spiral passage constructed inside the pyramid as it grew, used to raise blocks for the upper 2/3 of the structure, while a shorter external ramp handled the lower section. Engineering firm Dassault Systèmes modeled the proposal in full 3D. The construction physics work, and on the northeast corner of the pyramid, approximately 80 meters up, there is a visible notch, a recessed section in the outer masonry that has no agreed explanation in conventional Egyptology. In Houdin's model, it is exactly where it needs to be, a turning bay where blocks pivoting up the interior spiral would be rotated and redirected for the next section of ramp. That notch has been there for 4,500 years. Nobody has explained it any other way. In September 2025, a peer-reviewed study in NPJ Heritage Science, a nature journal, proposed something more specific for the upper construction phases. The Grand Gallery, the 47-meter sloped corridor inside the pyramid, may have functioned as an active mechanical system during construction, a counterweight assembly on internal sliding ramps, using rope and beam mechanisms to lift blocks upward through the pyramid's interior. If this is correct, it would explain something the standard model never has: why the Grand Gallery exists. It has no clear ceremonial function. It is positioned precisely where a large-scale lifting mechanism would be required. The paper's authors argue the pyramid may have been built partly from the inside out, not layer by layer from the base, but using the interior itself as working infrastructure. Neither theory is proven. Both survive engineering scrutiny that the external ramp does not, which raises the question this video is actually about. Why, given that engineers have been pointing to these specific failures for 30 years, does the external ramp remain the default answer in published archaeology? Part of the explanation is institutional. Revising the standard model of pyramid construction requires accepting that the dominant answer in the field was never properly stress-tested. That's professionally difficult. The external ramp has one genuine advantage over every alternative. It requires only tools and methods that can be independently documented from the archaeological record. It's conservative. And in academic publishing, conservative answers survive far longer than the evidence warrants. Part of it is that the Mer papyri, the contemporary construction records found in 2018, describe the logistical operation in vivid detail, but they describe transporting casing blocks by boat and sledge. They don't mention a ramp. They don't describe how the interior granite structure was raised. They are, in other words, evidence that the ramp theory is consistent with, not evidence that it's correct. And part of it is this: the alternatives require crediting the builders with a level of engineering sophistication that the standard model has consistently resisted, not supernatural sophistication, not knowledge that violates physics, just a more deliberate, more innovative approach than the textbook has ever been comfortable attributing to a society from 2,500 years before the Roman Empire. The Great Pyramid was built by human beings, skilled, organized, inventive human beings, working at a scale and to a precision that we have systematically underestimated. The peer-reviewed literature, structural engineering analyses, material science studies, a 2025 paper in a nature journal, increasingly points toward internal mechanisms, counterweight systems, and construction strategies we haven't fully reconstructed. What the evidence shows is not that the pyramid is inexplicable, it's that we've been explaining it with an answer that doesn't survive scrutiny, and we've been comfortable enough with that to keep teaching it. Safe isn't the same as correct. Here's the question worth leaving open. Which ancient structure do you think has the weakest official explanation, not the most dramatic mystery, but the widest gap between the textbook answer and the actual evidence? Tell us in the comments. And if you want to go deeper on this, we've put together a complete guide covering 50 ancient discoveries where the official explanation leaves the most questions unanswered. Every site, every competing theory, and the published sources behind them. Link is in the description.